Good morning, everybody. I feel like I should maybe mention that I did a little thing in between my 2 terms at Mines, where I had a chance to serve as the director of DARPA, which is the only reason I'm qualified to be up on this stage right now. I actually majored in geology and did most of my programming in very ancient languages. So we will throw that part out, and instead, let me take a minute to just introduce our amazing panelists. So. I'm going to start, though, by throwing out the provocative title that we have here. I think it's pretty much well understood among all of us that computer science is not dead. The conversation to have is what it actually looks like in the world that we're moving into. And what are those core kind of fundamental limits and capabilities around what defines computer science? And we have representatives from 3 sort of great stakeholder communities on the panel today. So that includes somebody from academia who is responsible for training the next generation, somebody from industry who is doing the research and development to actually make the transformations into work in close partnership with AI tools, and a representative of that next generation herself, who is a student going into getting a degree in data science and who is an avid user already of AI tools and developing new computational capabilities. So with that, I'm going to start by introducing the first of those aspirations in computing winners that you heard Terry mention. So she'll be one of the first voices you get to hear from, and that's Maria Cuevas. Maria, why don't you come on up? So Maria is a very recent graduate of Columbia University, and she has a BA in astrophysics. And as I mentioned, she's a 2026 awardee of Aspirations in Computing. And she wants to change the world's ability to detect and study exoplanets. And she wants to do that by building new instruments and data-driven software to make that possible. So in the fall, she's going to be attending the University of Cambridge to pursue her MPhil in data-intensive science, and she hopes to be able to further develop computational tools for astronomical discovery. We talked about the fact that she has a huge, wide future ahead of her, potentially working in industry after she finishes her degree, potentially doing a PhD. I'm sure she's looking forward to talking to you more after the panel is over. Why don't you go ahead and have a seat and be comfortable? Yeah. All right, next up, we have Catherine McKinley. So Catherine's a distinguished software engineer at Google. And for about a decade or so, until very recently, she worked on obtainability and efficiency for Google's global infrastructure. But currently, she's doing something new, exciting, and highly relevant to the topic of this panel. So she's leading programs to eliminate entire classes of memory, concurrency, and other bugs, while simultaneously increasing developer productivity by using AI to transform Google's software foundations from C and C++ to Rust. See? She was previously a principal researcher at Microsoft and an endowed professor at the University of Texas at Austin. And her team's award-winning research spans cloud systems, programming languages, compilers, runtime systems, and architectures. So, okay. Okay, yeah. I will take the clapping cues from you. That was just me bringing my hands together. Okay, so last, but very much not least, we have Ken Anderson. So Ken's a professor in the Department of Computer Science in the College of Engineering and Applied Science here at CU Boulder. Over 28 years here, he has held numerous leadership positions, including being the Associate Dean of Education within his college, and he has been the chair of his department for the past 7 years. He's also been an active member of NCWIT, including pioneering by being part of the first NCWIT Pacesetters cohort and helping to lead and organize the Aspiration in Computing Awards for Colorado for 8 years. So welcome, Ken. Yeah. All right, I'm going to switch to sitting. So I think There we go. I got the thumbs up from the back. You know what? They couldn't have had it on, or you would have heard the unbearable screeching from the interference. So, okay. So, first of all, as I said, I think we're going to just lead with the punchline, which is computer science is not dead. But we did have a question that I think when we were prepping for this, we thought we assumed we knew how people would answer, but I'm actually not sure. So I'm going to do a little show of hands sort of a thing, and it's going to be a question around whether or not AI is separate or on a path to being fundamentally separate from computer science. And it's one of those sort of peer pressure questions. So when I ask you to answer it, I'm going to ask you to close your eyes, look down, and raise your hand if you think AI is, in fact, separate from computer science. So go ahead, close your eyes, and raise your hands. All right? Okay, keep your eyes closed. Now, do you think it's on a trajectory to become so? All right, a few more. Yeah. Okay, so I think we were assuming people would say no, but we said there's actually a lot of different ways to think about this problem. So I wanted to make sure the panel had that as context. So it was about in my very rapid, accurate calculation of hands, it was about 10 to 15% who felt that this is actually somewhat separate. And so this is a big part of what the conversation is getting back to what computer science actually is now, and what it might become, and what it needs to become in order to prepare all of us for this very complex and very dynamic future. So what we're gonna do is I've got some general questions for everybody. I have a few things that I might poke at specifically with our panel members. And then as we approach the last 15 minutes, we're gonna do our very best to make sure we preserve time to take audience questions. So let me start with this basic question about kind of the fundamental identity of CS. And I think I might start, Ken, with you, because this is really, I mean, you're in the heart of what the discipline actually is and in the transformation that we're going through right now. So, did the CS community bring this on them? Did we bring it on ourselves in a way by equating the discipline too much with coding and with this sort of low-level mastery? And have we lost sight of what computer science really is?
Yeah, I mean, computer science is both a scientific discipline and an engineering discipline. Engineering disciplines always turn to science to say, what are the techniques that are possible? What's the knowledge and concepts that are important? And then we look at how can we use that to engineer solutions that are efficient, productive, cost efficient, you name it. And so there are just fundamentals to the discipline that are not coding. Coding was always just a mechanism for taking those concepts and ideas and translating them into a format that the computers could then actually respond to. But things like data structures, algorithms, the techniques we use to build larger and larger systems, all of those things are where the intellectual contributions of computer science lie. And coding was just one way in which you could manifest those ideas so that it could then be transformed into a format that the chips could process. So it's always been, what I liked about coding being this entryway into computer science is that it helped new people to the discipline experience failure so that by having experienced failure, they could learn. So when we are teaching people how to become software engineers or computer scientists, it's always an iterative process. How do you think you're going to solve this problem? Try it, code it, run it. Oh, compiler says something's wrong. And you learn, and you get better, and you iterate. And it's always been that way. So one of my fears about generative AI is that, in fact, by taking away the need to be doing coding yourself, we lose that framework of, oh, I tried something and it failed and I learned, and now I'm going to try something else.
Yeah. So from an industry perspective, Catherine, what do you
how does that strike you? And what do you think are some of the fundamental limits of AI in its role in kind of in computer science?
So I want to take, I don't think my mic is on. Now it is?
Yeah.
I think it's not on.
There you go. Try now.
It's not lighting up.
Try it again. Try flipping it.
It's on? Okay. So if we think back on the early roots of computer science, now I'm feedbacking. All right. which I do anyway. All right. So we programmed in assembly language because that was the computer language. And it was actually controversial to introduce Fortran as a high-level language. You weren't going to be able to control the computer correctly, get efficiency, and you were never going to need very much memory.
They're gonna-
have very much memory.
Looks like they're going to bring you a mic.
Thank you. And so now so we had another set of languages that were better. We started with Pascal. Now we're using dynamically typed languages that people could get computers to do stuff faster, although debugging them was hard because they didn't have type safety rules. And so now what we're seeing is that Rust, and why we're pursuing it, lets you create correct programs much faster. So it's a much better language for the agentic coding, and it's a good language for humans too, although it does have a different discipline than lots of other languages that you learn, so there has to be a learning curve. So this is just the abstraction was always key in computer science, and this is just the next level of abstraction. The key challenges are human language is not specific enough. Vibe coding with just natural language prompts, that can't be how we do precise systems. You can't have life where you depend on your life to do this correctly, or the economic system to do this correctly. Human language is too imprecise. So it's clearly an open problem how we're going to be able to express things in ways that give us the guarantees that we want, because currently the specification languages, people have voted with their feet that they hate them, yet they're the way that they're definitely going to be part of the answer in terms of ensuring the code is doing what it's want. And then you have the social problem of, if you don't understand the details, how can you keep innovating, and how can you be a deeper contributor to this code base if you don't understand it? Well, we don't understand the assembly code that the compiler produces, so I do think we are on, that there is a language in which we can represent these things, but we don't quite have that language yet, and it's not natural language.
Thank you. So I feel like there's a whole back and forth we're going to be able to get to, but I want to also get Maria's perspective on this. So as somebody who is sort of entering this field and moving even more into kind of the data science side of it, what is AI and computing? What does that mean to you?
Does my mic people
There
hear
you
me? Okay, cool. I have a very complex relationship with AI. Like, I think that it has it will be really beneficial in the field of astronomy, especially now that we're going to have like all these telescopes generating terabytes of data, and a human cannot possibly parse through the data. Like, actually, I'm doing a summer project on that this next week, starting. Yeah, so I feel like from that lens of like using AI to help us improve our ability to detect things will be really beneficial. But like, from a student perspective, I do have an issue with generative AI, in the sense that I personally have a strong foundation in computer science because I did it way before AI became popular in the past couple of years. And so even if I were to use, I don't know, ChatGPT to help me with this coding problem, I will be able to understand what it's doing and even help improve it. And I feel like people that are entering the field and do not have the foundation and just use it will not be able to learn from it.
Right.
And that's the main thing that worries me from like generative AI and
Yeah.
whatnot.
Yeah, I think that's the question that everybody sort of has, is what is that baseline foundation that people need to know so that they can then partner effectively with the machine and be a responsible and ethical implementer of those tools. So Ken, we talked about this a little bit. What are your thoughts on like the direction that computer science in education actually needs to go? And what are those things that we absolutely cannot lose?
Yeah. Well, in thinking about what Catherine just said, these layers of abstraction that we build upon, in today's world, before generative AI, there's definitely people who lived in the world of high-level programming languages for their entire career, had a great career, and then there are the people that are below that level of abstraction, creating the compilers, making sure it all goes down to the machine and works the way you expect it to. And so one of the things I hope to see in this new world in which we have this new layer of abstraction is, again, common set of roles. There are people who will always work above that level of abstraction, never worry about how those tools are built, but there's going to be the people below who are creating the tools and techniques that work under that layer of abstraction. I believe computer science education is going to be producing those people. And in order to do that, they have to gain expertise in things like typing systems. They have to gain expertise in, if you have a program that does X for one person, how do you make it do X for 10 million people? Because that's a non-functional requirement, scalability. And as you increase the level of scalability, anyone that's in industry now knows you have to abandon certain data structures that are comfortable and move to data structures that are unfamiliar, and techniques that are unfamiliar. You have to gain that expertise. Computer science education has to teach people those things. The only way you're going to be able to guide Claude Pro agents to produce a scalable system is if you know the techniques that produce and actually allow scalable systems to run, so that you can guide the agent to what is actually what you're looking for. The agent's not going to be able to tell you, at least not yet, that, oh, you need to abandon this data structure, start using this data structure. If you're using a user interface, you have to use pagination. I mean, all these things. And there are a lot of different types of non-functional requirements. To make something secure requires lots of new techniques. To make something reliable requires lots of new techniques. And so I view computer science education in the future is going to be, how do we train humans so that they know all of that information, that they've got the experience learning through failure these techniques, so that they can then apply them and guide AIs in the right way.
Yeah. Catherine, what do you think? I mean, as someone who will be hiring these people.
Well, first, I want to go back to something you said earlier about you need failure to have insight. You also need success to feel motivated, right?
Right,
So
it's a
it
balance.
is this interesting mix of pedagogy on having some successes and understanding the ways in which things go wrong when it goes wrong, so you can fix it. And so in terms of training, we still need deep computer science domain expertise across all areas. There are going to be some new areas of computer science that we didn't hire in very much before. For example, how you make the agentic AI, generative AI, not produce hallucinations for your code, or just return true when you ask it to verify that the code is correct. So there's a framework around that that's very deterministic, domain specific, and you need domain experts. Now, how are we going to? We have a bunch of people trained now across the spectrum. Google is doubling down on hiring new people and training them, and we're not laying off people because we believe this is an opportunity for innovation, that we're we're going to take these gains in productivity and we're going to move faster, do things better, be more secure, be more innovative with all the productivity gains we have. And we've always been limited only at Google by we are a very ambitious, innovative company, and we've been limited by our tools and how fast we can move, and now we can move faster. So, but going back to the training question, what are we going to train them? How do you create a domain expert in low-level systems? Is they have to work in that low-level system, and if AI is generating all the compiler code now and doing a better job, how do you give the person enough expertise and so that they can now suggest innovations that the AI can't suggest, because there's not a limit to what humans can do, and AI is definitely learning from what things we did in the past. So I read a very interesting paper, and I can't recall what university it was, but I met the people at the CRA undergraduate to PhD program, and what they had done was take a regular AI and have students use it for an assignment, and then they took a AI with the pedagogy of how to learn on top of it, so succeed and failure, and testing for deeper understanding at each phase. And the AI that was surrounded by this pedagogy resulted in people who were better trained who did better in the course on this assignment. And that's the kind of tooling and learning that we can accelerate with the right pedagogy, with the right human interface to the technology, considering what we want the humans to come out from the technology versus what we want it to do, but we also want the humans to be in the loop. Very related to the first remarks of the day.
Yeah. Thank you for those.
Yeah.
Material.
Those were
that was a
great.
really great start.
I
Yeah.
was inspired.
Yeah, and I'll just say, to build on Terry's remarks, one of the things I wanted to say at this panel was that computer science has always been about people working together, despite the stories of, every now and then there's a unicorn who does something amazing all by themselves. Fred Brooks in Mythical Man Month was reporting on in a software project in industry in the late 60s that involved 1,000 people working together. So it's always been about people working together to produce things, and I think that's never been more true. We have to make sure in this world where we have all these generative AI tools that, as Terry alluded to, is designed to isolate us, that we fight back against that isolation. We don't need that. We need to be in rooms together, we need to be talking and collaborating and coordinating together.
Yeah, absolutely. So leaning in a little bit to that human note, Maria, what do you think about are some of the human skills that you feel are more and more important? Have you've had this interesting visual where you're bridging the gap, right? And you started with learning your core sort of technical skills. Do you feel like there are human skills that people need to lean into now? Things like collaboration and metacognition, for example.
I guess I want to talk on the topic of innovation. Mm-hmm. Something that I've noticed that AI cannot do is produce new knowledge, in my opinion, especially in the field of astrophysics, where you have to have a lot of context. AI sure can program anything, but if it doesn't really understand the context for it, it won't be able to properly produce code. So I feel like having that background is really important. And also, but I personally haven't experienced, AI has not affected me, the field of astronomy much.
Do you worry about students who were just a couple years after you? Do you see a difference, or is it too soon to tell?
I mean, I see a difference. You go to the library and everyone has ChatGPT pulled up, and it just has become the norm. And my friends who did take coding classes, because it was a requirement, they just use ChatGPT to get the answers and whatnot. But I feel like now there's a lack of learning, like it was mentioned earlier. And yeah, that will make it harder for like the future people in the field, in my opinion. Because if you're not really understanding the fundamentals, and you won't be able to outsmart AI.
Yeah.
And that's when you become not useless, it's an extreme word, but but
Yes.
I feel like there has to be like, I don't think this is necessarily the job of the students, but I feel like it's a job of like the institutions
Yeah.
to like restructure their curriculum so that students are more aware of how like AI operates and learn how to navigate it better, which I think has not fully happened.
I mean, it's amazing to think how quickly this has been going on,
Yeah.
right? So I think in university timelines, this is happening like at faster than the speed of light.
Yeah.
And I promise that Ken and his department, and similarly the departments back at my university, are working really hard on trying to figure out how to make this work. But the technology changes by month,
Yeah.
right? And so it's an interesting kind of a race. So maybe along those lines. How do institutions help guide this? So let me ask Catherine, how does industry and maybe how does government play a role in responsibly moving this technology forward?
So we have to start by using it ourselves responsibly, and part of the reason that Google got caught flat when with technology that it invented being integrated and made into a great tool in ChatGPT was we were very conservative with respect to controlling it and what harms it might do. And so we're still not doing a good job of that. And that's an area where controlling so controlling what it does in an ethical way and making sure our engineers and our customers and our users all aren't surprised by and disappointed in us for producing terrible results or offensive results or dangerous results is a huge issue. And recently, so with the Mythos release, where they were able to create attacks faster than anyone can fix them, as well as find memory vulnerabilities, is a serious problem for the security of all software in industry right now, and having regulation on who and how that can be used seems to be a wise step, and we're behind that. And I think people understood it was coming. They didn't think it was coming this quickly. And so that's been that kind of legislation from the government, and having thoughtful, ethical people and good scientists, as well as coupled with good policymakers in government, is a struggle right now. And but we definitely are, as a country, behind. Some of the other countries have put in place better protections, but nobody's really ready for the level of capability we have right now, and especially for the ability to harm our economy and the security of our nation right now. Like it's very serious.
Yeah. Yeah, it's a scary time, and things are moving in many, many different directions. It's having come out of government, I can tell you it is hard, for government to get its arms around all of these different pieces, especially when there's so many voices with different opinions coming from all directions. And then even when people start to think that they've got their arms around it, a new model is released and everything has been upended, right? And so it is definitely sort of a quicksand kind of a moment. When we were getting ready for this panel, we talked about things like safety and regulation. And Ken, you weighed in heavily on ethics.
Yes.
You want to talk a little bit about your thoughts on that? And
Yes. Yeah, so I mentioned, so computer science has an aspect which is part of the engineering discipline. And if you become an engineer, you know that ingrained in engineering culture is the idea of ethics. We are building mechanisms and services and technology that goes into society, and we have an ethical obligation to make sure that those systems are safe and that it helps people at a very high level. And I remember actually being exposed to this for the first time when I was a graduate student with a project that had several software engineering professors. And I learned that they would only fly at the time, and this was back in the late 80s, early 90s, they would only fly on Boeing when they were booking their trips. And I asked them why, and it was because they said at the time, I don't know if this is still true, but at the time, Boeing designs had 3 or 4 levels of redundancy for every system. And that was an engineering ethical obligation. If this system fails, this is the backup. If this one fails, that's the backup. And that type of having this ethical obligation, we're going to do everything we can to make sure that our planes are safe. You know, it was very influential to me as, you know, this is what we have to be teaching our students to do. So I think grounding our students in ethical frameworks is really, really important. I just want to shout out Casey Fiesler in the audience. A lot of her research is aligned with this, and she's amazing in multiple ways. But I also wanted to say I went to a talk earlier this year, and I brought up my phone just to remember this one slide. As our students leave our programs and go out in industry, there are going to be people in power coming at them saying, we're doing this work aligned with a certain philosophy. And this one slide captured some of the philosophies that are currently associated with AI right now. And they are called, I'm just going to list them off, transhumanism, extroplanism, singularitarianism, cosmism, rationalism, effective altruism, and long-termism. And so as a software engineer, or as a member of the computing community, you'll go to an event at Silicon Valley, someone who's powerful in the industry will be talking about one of these things and will claim this is an ethical framework which is guiding our work in AI. And I won't belabor this point, but when I first heard a presentation on effective altruism, I was going, okay, I had an intro to philosophy class when I was an undergrad. And from that class, I know that this is not an ethical framework. Right? So just one class as an undergraduate was enough to arm me with the knowledge to say no, that's not ethical. That should not be guiding our actions. And so we need ethics integration integrated deeply so that not only can we be doing, one, the long-term goal of I'm producing systems that I've thought through the implications and I'm trying to keep people safe in some way, but also when I'm confronted by someone saying that this is an ethical thing we should be doing and it should be guiding our work in our companies, that I have the ability to say, is that ethical? Like I'm not taking it for granted, I'm questioning it. And so I think computer science needs to develop collaborations. We have nascent collaborations with our partners in the humanities to make sure our students are exposed to these ideas and have these ethical frameworks that can guide their work. We actually have, as computer science here at CU Boulder, added an ethics requirement for our students, and they can gain that, they can earn those credits by taking classes in philosophy or in other humanities departments, because we think it's just really important that they be exposed to these ideas.
Yeah, no, I love that. Yeah, it's interesting. The timing is interesting on this. I just came from a workshop last week where we were focusing on the question of teaching character in engineering education. And it's actually kind of controversial because while engineering is sort of rooted in ethics, it is also somewhat rooted in this idea of, you know, we build the best system possible and how it is used is for others to decide. And I think that we are we're at this point where we have to change how that, you know, how we think about that, right? And that it is not simply equations where others then dictate how they might be used. So. Yeah, so we touched. Yeah,
I just
please.
riff on that a little.
Yeah.
By building engineering systems, you're always making trade-offs because you have limited resources, you have limited time to market, and so you are always choosing different points in this spectrum, and it's the engineering's ideal that I'm building the perfect, most best system that I can. That's never true, right? You're always compromising on something, and there's certain things you shouldn't compromise on, and that's where we need to be more rigorous on how we enforce our values.
Yeah, absolutely. So I want to also bring forth a little bit more of the optimistic view, right? There's a lot, that is absolutely possible that never would have been before, and so I'm gonna turn again to Maria as our bridge person who was moving from one way of thinking into another. What are there things that you can imagine solving? I know you mentioned just dealing with massive amounts of data, but are there other aspects of your chosen field that you could imagine doing with AI that you couldn't have done? So the way that people were talking about astronomy, for example, and exoplanet searching 5 years ago versus what you think could be possible 5 years from now.
Something that I've noticed that I think I mentioned this earlier is I don't know how to explain this so people can understand, but
We'll take a tutorial.
okay. So there are these things called like chips. So like people are like building like chips to make like more compact versions of like instruments for telescopes. And the chips are very complicated to make, but this professor was telling me how he like built this like machine learning model that is able to like engineer a chip in like minutes, something that would have taken months for a PhD student to do. So I feel like it's definitely increasing, because it really depends on what you care about. A lot of people in astrophysics, like a lot of astrophysics right now is like coding. But there's people that strictly only care about the science and they don't want to deal with code. Matter of fact, coding is not even part of the curriculum. You have to go out of your way to learn that on your own. So I think AI does help with that, bridge that gap, and make it easier for people to solely focus on their science, and which I guess some appreciate. Yeah, but also like going back to the data thing, it will allow us to like make more analyze data in a way we wouldn't have been able to before, and like make more discoveries and things like that. But I think like AI has been used in the sciences for a long time, specifically machine learning. So I don't think it's something new, because we're still now not necessarily using like AI agents to do the work. We're just making like more complex models to do things.
Yeah. Well, thanks for reminding us of that too, right? AI absolutely has been, in whatever form it is, whether it was decision trees, whether it was machine learning, and whether it's this sort of crazily, insanely scaled version of machine learning that it is now, it has been something that people have been using for a long time, and we're simply part of an evolutionary cycle, which does seem to be moving, admittedly, much, much faster than it ever has before. But it's actually a really good point. So, are there, would either of you like to chime in on things that?
So just democratizing of getting computers to do stuff you want them to do is just astonishing, and enabling other sciences besides computer science to accelerate their levels of discovery, the potential for improving treatments for cancer, the potential for improving the climate. There's just huge science problems that we face that, given the right data sets, now that AI can help us solve those problems. And for example, the genome data set, apply AlphaFold was inventing proteins because we had a great data set, because humans decided that was a good data set to prepare. So what other data sets do we need to prepare so that the sciences can move forward? And then all those people who want to get computers to do stuff that are both trivial and deep, that they can be assured that that's what's actually happening instead of return true, so we build confidence in the systems we build as well.
No, I think,
You don't have to. I've got a different question
Yeah.
for you then. Okay.
yeah, go for it. That was great.
Okay. So I want to at least take a moment and step away from AI. It is obviously the topic that is very hard to get away from, but there are other things happening in the world, right? And so, for example, while it's still maybe a little bit of an opinion exactly on the true impact of quantum computing and what it's going to do. I mean, people are trying to figure that out, and there's a lot of competing architectures and a lot of technology that's moving in different directions. What are other things about the future of computer science, Ken, that you think maybe we should take into consideration?
Yeah, quantum computing is certainly one. We've got people in our department that are working on quantum secure cryptography, hedging against the fact that they can come up with cryptography that's secure against quantum computers before a quantum computer is created that can break all known cryptography. And that is a discipline that gets mathematical very fast. Every time I come to see Huck Bennett, our professor, give a talk on that, I just have a bet with myself, how many slides can I hang in there with him before I'm struggling to keep up. And I think there's some really interesting opportunities in terms of distributed quantum systems and how to program them and the things that they will enable in terms of being able to truly tackle problems that require extremely large state spaces. It's very exciting and transformative. I am not yet ready to give up on the fundamentals of software engineering. I think software engineering is going to be, how we do software engineering is going to be a future of computer science, figuring that out. What are the roles? What are the positions? All of that. It's been interesting because of the model for Claude that came out in February. Since that day when it was released, I think software engineering has been kind of in this lurid fever dream. There are software engineers that I follow through their blog posts or newsletters or whatever it is, and they all lost their minds in February in terms of the increase in capabilities. And we'll never, I don't have to work with anyone ever again. I can just use my agents. They're all my junior software engineers, and I just guide them to build my systems. And it took them a couple of months, but then I'm starting to see some of them reflect now. It's like, oh, I was able to take advantage of all of that because I already knew how to be a software engineer. Right. I already knew how to write a spec. I didn't have it generate test cases. I wrote the test case. And I made the agent keep working until my test cases passed. And so that to me just highlighted this journey of just a couple months because of the speed at which this is all going on is reinforcing those fundamentals to me, that someone who's going to be guiding these things does need to be trained on what we expect from our software engineers. And
yeah,
so
we have our own neural networks.
Exactly, we have our own neural networks.
Significant training and reinforcing. Yeah.
Exactly.
Yeah, yeah.
So that's I think is my opinion on that.
And I would just add to that, robotics and the interaction with the physical world,
Yes.
and self-driving cars, that this technology is really starting to take off and has a real opportunity to make a big difference in society as well. So that's, I see as an important area that has, as Peter Stone from the University of Texas, who's been having soccer robots since like for 30 years. He's like, we haven't seen our moment yet in robotics, right? And we're on the cusp of that.
Yeah. Yeah, the physical overlords are a little bit behind. But yes, on the other hand, working with AI tools will likely help accelerate some of the physical development as well. So that's actually particularly exciting.
But the math and the things you have to learn and the way you specify what the robot needs to do, that's still super hard programming, right? And we need new programming languages and new ways to specify things that are a lot richer than the current ones. That these properties that aren't a math equation, but have to be observed in practice to be debugged, maybe more of those will be correct by design, or engineered by design is probably the better word for those properties.
So as we're going to start moving in towards maybe a little bit of a lightning round of some questions before we move into open Q&A. But before that, is there anything we haven't talked about that you think is important on this topic that we should be sharing with everybody?
Yeah, I'll just share one more thing on the software engineering front. So I mentioned Fred Brooks before, and so he's famous for writing the Mythical Band Month, which was, he was the lead on the hardware design for OS3, the mainframe 360. And then that had gone under budget, was a great project. Everyone thought it was a smashing success. So they made him the manager of creating the operating system for that same hardware. And the OS 360 project was not under budget, it was over budget, and it was delay after delay. And the Mythical Band Month was him sitting down and saying, what went wrong? Software engineering is just so much more complex than hardware engineering. Well, he wrote a paper in 1986 called the No Silver Bullet. And at the time, if you were around at that time, people would say, hey, if you just follow this software engineering technique, it's going to solve all your software engineering problems. It's a silver bullet for software engineering. And so then he wrote in the title, there's no silver bullet. And he basically said, a definition of a silver bullet would be a single technique that by itself led to an order of magnitude improvement in the production of software. And then he spent many years after that saying, nope, that's not a silver bullet. No, that's not a silver, no, that's not a silver, no, right? My claim currently is that Fred Brooks would be here today saying generative AI software engineering tools are not a silver bullet. And as one point to that, Uber, the CTO of Uber was recently quoted as saying, I'm spending all this money on Claude Pro licenses, and I cannot tie that expenditure to an increase in efficiency, an increase in the delivery of user visible software features, the reduction, 10 times reduction in bugs. So generative AI tools still need to prove themselves. And so I think we should be mindful of those things. There's a lot of hype about what these tools can provide. And I do think an experienced software engineer, given those tools, can, in fact, that person could be 10 times faster. But that's not what Fred Brooks was talking about. He was talking about industry being 10 times better at something. I don't think we're there yet.
Were you going to say something, Franca?
This is the most exciting time ever in computer science. The world is changing, and it's changing faster than it ever changed before. And you can impact how it changes, because when it's changing, lots of new ideas get tried, and lots of new approaches that people wouldn't consider before now become feasible. And I find it like I'm at the age where I could consider retiring or not, and I said, hey, what do I want to be doing? I want to be part of what's ever going on in generative coding and how we're going to build systems in the future. So I hope you all will double down and make a future that's super exciting and ethical and a human process that works for all of us.
Thank you. I feel like we should clap.
Hear, hear.
But we're not ending there. It was an amazing moment.
Well, I'm optimistic. There's a lot of optimism.
Yeah.
But I'm also scared to death at the same time, right?
Right. Because the uncertainty bars are just enormous, and they're in many, many different dimensions at once. And that is hard for us to know exactly how to steer things. So we'll do a real quick lightning round. This is what each of you, like if there's a piece of advice you would give to a brand new freshman entering computer science. I was gonna ask Maria to go first, but you wanna think about it, or do you?
I mean, I can start. I guess one piece of advice is not to listen to what people say about computer science and AI. Like, I was told by this person, why would you pursue a master's in data science when AI exists? And I feel like those are people that are not fully educated on what AI is to begin with.
Yeah.
So I feel like not listening to that and trying to find your own place in CS, because it's a really wide field.
and you can make it work. It will just require a lot of like adapting to this
Yeah.
new era.
And the world still needs more computer scientists.
Yeah.
So,
That's like, I just want to repeat that.
yeah, right?
That we are going to need more computer scientists. And the idea that when there's lots of change and uncertainty, people are nervous, they want a sure thing. So an example of this was the Houston Chronicle wrote an article about how much money you could make being a pharmacist. And the next year, our pharmacy program had an overwhelming, and it was a secure job, right? So then we had millions of people wanting to be pharmacists because the parents and the kids were influenced by a sure thing. And we don't have a sure thing right now. We have lots of uncertainty, and that makes people really nervous. And when leaders of the industry say things like, oh, I'm going to hire a lot fewer people, it induces a fear. And I don't think that that's where we're going at all. I think we're needing more computer scientists, more people who know and understand how computing systems work and get them to do amazing things.
I think I would say to the new computer scientist starting out, do the work. Like, computer science.
Don't cheat.
Don't cheat. Computer science is hard in lots of different ways, and it's humbling, but do the work. Scientists and engineers like it when things are difficult. They rise to the challenge. They work in groups towards solving challenges. So we don't want things to be easy. We want it to be difficult, because then we have a path towards learning and mastery, and we gain a great satisfaction from having done that. And so this has been true for a long time. If you're getting into developing software systems, do something that scratches an itch for you personally. So find a software system that you wish existed and work towards making it exist. And learn what it means to go from, oh, here's a program that finally for the first time compiled and actually did what I wanted it to do, to an application that I use every day and rely upon. Because the difference between those two things are really, really far. Getting that first thing to work is just the start. And so have this mindset, I'm ready to learn, I'm ready to do the work.
Yeah, do the work. Thank you. Okay, so audience, I gave everyone fair warning. We were going to move into a Q&A session. So I'm wondering if that means we will have the usual silence where no one wants to ask the first question. Oh, look, there we go. So we're going to be running mics around the room, and feel free to also let us know if you want to direct it to a specific person, you're welcome to do that as well. So.
Yeah, so just a bit of a general question. Do you think that we're ever going to achieve fully thinking machines? Like, is generative AI eventually going to reach the point where it is actually able to generate its own concepts and build upon them?
Anybody want to take it?
Yes, so is AGI achievable? Well, I have a friend who's a philosopher, and he talks and talks, that's all he talks about. Can't get him to shut up about it. And he's way better qualified, I think, in actually talking about what this is. He gets very quickly into what is sapience, and humans have a certain way we're implemented, and we believe we have intelligence. That doesn't mean that there aren't other ways for that to be implemented. So there's a possibility. I would say that what we're seeing today is still mimicry, very sophisticated mimicry, but not intelligence. My background is in software engineering, as is clear. I don't consider myself an expert to be able to say, yes, we're going to actually be able to achieve it. But that when I referenced singularitarianism as one of the things, that's the whole thing of getting to singularity, where it does become sentient, and then it designs the next species of, that's where transhumanism comes in. So no, I personally don't think we're there yet. I don't know if it's going to be possible.
So I'm also not really qualified to answer this question, but I saw a very interesting blog post or interview with a neuroscientist comparing how LLMs work today versus how our brain works. And the neural networks are still basically searching all like if it were your brain, your entire brain would be lit up and you would be confused because our brains are super efficient. So when we talk, a certain part of our brain is lighting up when we talk to our husband or me, when I talk to my husband versus when I talk to work versus explaining a concept. So our brains are really working differently. So can you implement it with chaotic search, essentially lighting the whole thing up? Maybe you can, but so far not.
Yeah, I've always thought that it's almost like it's the wrong question. You know, do you want the machine to replace the human, or do you want the machine to become an ever better partner so that the combination of the two is something unimaginable, and unimaginably good? Let's qualify it there. But this, I think, part of the reason everyone struggles too is kind of what the definition is of general intelligence seems to be very different for a lot of people. And I know folks, for example, at Microsoft, who believe we've already achieved it, but their definition is very different from, you know, sentience, for example, or this much more comprehensive thinking capability. So, all right, who else?
Hi, thank you for the great panel session. My name is Promise April, and I'm a rising fourth-year PhD student at Cornell University and studying computer science. So this was a very great conversation. I just had a question for Katrin and Professor Ken. So I'm thinking about like ways academia and industry can collaborate more on these problems, because overall there's still some pros to using this generative AI and these new technologies, but then also there's still some cons, which are the problems that a lot of people are working on. So I think one thing I've seen in the academia is that people are working on these Gen AI problems, but some of them have limitations, like compute resources and just like the financial, like the expensive part of things. And I know like there's some grants, like some companies will grant grants on some specific areas. So I was wondering, like, is there like more opportunities for academia and industry to collaborate on these problems in Gen AI?
Of course, and we are collaborating with academics all the time. We give grants for universities to have access to our models, and that has to be part of the partnership. But we need to continue as a country, especially in the US, investing in science and helping make this happen. If professors can't hire graduate students, then none of this can happen.
Here.
Thank
Yeah.
you.
Yeah,
I was just going to say, like, also if there's any specific opportunity, you can also list them as well.
So there are, and we need our universities to have access to this technology so we can train the next generation both in inventing it and using it. And I think that's happening at some level, but it can always be more and better. And like Google has open calls for proposals, and Microsoft has lots of programs for proposals. Anthropic is just giving away, since they're not making any money yet and apparently not concerned with that yet, they're giving away, a ton of credits to universities. So those are, and running on Google hardware. So that's an opportunity for the inventors and the users of this technology to work together.
Yeah, and then on the education side, we have faculty who are, of course, going after those opportunities, applying for those grants from Amazon, from Google, et cetera. We have actually at the campus level, our Office of Information Technology, trying to make it easier for us to access those types of cloud computing resources so that we can bring them to our classes. We have our faculty who are innovating, and then our own department is investing. And the hard part about that is you pick a technology, you put it in your data center, it's already obsolete. But it's not obsolete for education, right? Because you can train and teach students a lot, even if you're not on the cutting edge of that hardware. So you have to decide when you're gonna make it, how much of an investment you're gonna put in. So we're doing all of those things. And then of course, academia in general, I wanted to highlight that there's some work out of Northeastern by Carla Broadley, who is tracking all of the work that computing is doing as a discipline to bring like BS, Bachelor's of Science in AI, Masters in AI, PhDs in AI. What does that curriculum look like, and how is it different from a computer science curriculum? And so people are thinking through, how do we make sure students have the math they need to then take their first machine learning class and the like, and optimizing that to make it happen faster. So I think we're seeing a lot of things happening both at the curricular level and then faculty engaging with industry to do the research. And what Catherine said is absolutely critical. Our nation needs to continue funding basic science so that we have the ability to get grants and then bring in students to these things at all levels.
Thank you so much.
Hi, my name's Bia, and I'm a senior at NYU, or I guess I was a senior at NYU until like 2 weeks ago. You guys were talking about we need more people in CS, and I guess one thing that I've seen a lot is that we have a lot of people that want to be software engineers, but not as many people that want to go into research. And maybe it's just my experience, but I don't know, I was wondering if anyone of you guys wanted to speak on, or could speak on, why people are kind of research averse and what we can do to make people want to do research more, if that makes sense, or what you guys think about people wanting to go into these fields and what type of computer scientists we're getting and what we need more of.
That's
Yes.
coming from the world of research. It's like, I don't know. I've always been surrounded by people who wanted to do research. So, Ken, maybe your perspective.
Right. Well, I think as you come out of high school and you come into the undergrad education realm, research is a black box that you don't know anything about necessarily for many people. So there's this fear of what is it exactly, and it's a fear that if we can get past that barrier, you find out very quickly it's a group of people, none of whom know the answer and are all trying to figure out what to do next. And then you iterate and you iterate and you work with people. So what we encourage in the College of Engineering and in our department is for students to not be afraid of going to faculty office hours and using that time to say, hey, I'm very interested in your research program. Is there any way that I could, attend your research group meeting just to see what it's like? And then the college incentivizes, by providing funds, the ability for undergraduates to get involved in research. So the answer is to really make sure that it's that you're taking away any fears from just not knowing what it's all about, and then providing opportunities, funded opportunities for people to get involved and start that. The problem we've been facing, of course, is that the allure of industry has been so strong for so long in terms of I can get out there and get a very well-paid job. And so then I'm just focused on going after that goal, and a lot of people are heading in that direction. But you can get a lot of expertise by engaging in research early on a topic that then helps you with those goals as well. So it's just really, I think, making sure people have the opportunity to get involved if they're interested.
So, and there's good science behind that people who have undergraduate research experiences like it and at a higher rate and go to grad school and are glad that they did it. And the Computer Research Association Widening Participation Committee has a program called the Distributed Research Experience for Undergrads, and you're a little late, but you could still probably get one. and so what that does is partner undergrads with a research professor, usually at a different institution, and that helps reach people whose departments don't have people doing research on their faculty who are more focused on undergraduate education. And so then you get to work with a faculty member and their grad students, and then some people don't like it, and then they make the good choice not to go to grad school. Some people really like it. That was my path to, I had no interest in getting a PhD in computer science. I never thought about it for a single second until I said to my professor, can I work for you for the summer so I can hang out with my boyfriend? And although I didn't add that last part, and I broke up with that boyfriend and met my husband, and I had the best research experience and it was amazing. I realized they didn't know all the answers, and so I made a decision right then to go to grad school. And without that experience with my professor, I wouldn't have done that at all.
Yeah, so, and I'll lean into it. I think it's also a skill set that people are learning, even if they don't go into research. The comfort with uncertainty and ambiguity is such an important skill, and maybe an even more important skill in the age of AI. I don't know, Maria, you've been involved in research, so do you have any opinions on how people might be more encouraged?
Well, the current funding situation is like really difficult to get into a PhD program to begin with. And yeah, I feel like based on what I've seen, I haven't personally seen that CS really markets the research aspect. Like when people go into CS, I think like we always, like I personally am guilty of this. I automatically think of like software engineers. I think of like, I don't know, working at Google or doing something like that. And I feel like maybe there needs to be a change in that, and like professors need to like market the research aspect of it. And I feel like that might be a reason as to why people don't feel drawn to it, because it doesn't become like something that you think of automatically.
That's a really good point. Yeah, and I think a lot of times when people do think of research, they're thinking of laboratories or something a little bit more traditional.
So at UT, when I was a professor at UT, we started a seminar series, and one of the things we said to all the undergraduates was, here's how you get into research. This is the benefits of a research career. Most people in computer science grad school get paid full time, because a lot of, especially students who don't have a parent who went to grad school, don't understand the funding situation. And so just having seminars where you inform your undergrads, for those of you who are professors, is a great way to open their eyes to the possibilities of doing research.
Okay. Well, that is actually a really good note to basically wrap up on. My counting clock says we have 38 seconds left, and I will use just a couple of those seconds to thank everybody for being interested in this topic, for being here, and for being part of this brain trust. So thank you all.